Well, with apologies, a solution to our problem here is going to kind of be spread out in a thought I saw an integral down there. It's spread out in a maybe a convenient format because I had to wrap it around some other stuff here from physics. Okay, I'm short on boards. Okay, well, we know, I hope now, that if you have interest rate R compounded n times a year, then every time you compound it, you're going to multiply by 1 plus R over n. You're going to multiply the principal by 1 plus R over n, and you're going to do that n times every year. So in 2 years, you do that n times t times. The number of times you do it is n times t. That means that your principal is whatever you started with, multiplied by that factor by which you multiply it, the 1 plus R over n, and you're going to multiply by that this many times, so it's going to be this to the nt. Okay. So, for example, 8% annual interest compounded quarterly, and you invest $4,000. What's your function? Well, your function is, let's see, n is the number of times you compound, R is your interest rate, which is 0.08. So we can immediately write down the function. It's principal $4,000, okay, that's your P naught, times 1 plus 0.08 over 4, now we're used to that, raised to the 4t. Okay, and we very recently developed that idea in class. So the question then is, how long does it take our money to double? Actually, now that's the last question we want to do. We'll hold that question, okay, because we do want to answer that question. But let's continue with the thread here, and then we'll come back to that problem. Okay, so here's our principal function. Of course, 0.08 divided by 4 is 0.02, and when we add that to 1, we get 1.02. And then that's raised to the nt, but of course n is 4, so I should change that n to 4. Here's our principal function. To find the principal after 3 years, how do we use this principal function? Well, 3 years is how long you allow the interest to continue compounding. Now that's going to be t. T is the number of years, so 3 years, t is 3 years, so you get p of 3. And of course, plugging in 3 for t here, we plug it in here for obvious reasons. So we have 4 times 3. Everything else stays the same, so p of 3 is equal to this. Replacing the 4 times 3 with 12, it's $4,000 times 1.02 to the 12th. And that's easy to calculate. You punch it in your calculator. Then the question is, I'm not going to give you the answer. Plug it into your calculator. $5,000 some dollars. How long does it take to reach $10,000? Okay, now that's a little different question, isn't it? Because we're not given the value of t, so we don't have anything to plug in. Okay, but well, we want to find t. That's what we want to solve for, and we're told that our principal is going to be at that point $10,000. Well, P of t is the principal that we get after t years, so we're going to let P of t be $10,000, and of course I write that out. Okay, how long is your t? And this is what you want to find. P of t is your principal after time t, so P of t is $10,000. So we take our principal function and replace P of t by $10,000, and we get this equation to solve for t. So here's our equation. How do we solve this equation for t? Well, this is just another simple exponential equation of the type we've been solving for a couple of weeks. What do? Well, we divide both sides by 4,000. And what do we get? 1.02 to the 4t equals 2.5. 4,000 goes into 10,000, 2.5 times Divide this side by 4,000, well, we just get the 1.02 to the 14. And we just translate that to logarithmic form. Our base is 1.02. So it's going to be log base 1.02. Log of what? Well, log of 2.5, and that's going to equal our 4t. Now, this is not an integral sign. When I saw it, I thought so. It's just a crooked arrow saying we go from here to here. And the only change we've made between here and here is we express log base 102 of 2.5 as log of 2.5 over log of 1.02 using the third basic relationship that we use in solving exponential and logarithmic equations. And then we work that out. Now I said, okay, I think it's going to be something like 11 years, and it's right between 11 and 12. And then how did I do that, incidentally? I used the rule of 72, which I'll share with you, because it's a very handy thing for figuring out, long term, how much money approximately how much money you're going to have. Rule of 72 says we take the annual percentage rate, which in this case is 8%, and divide that into 72. Well, we divide that, we get 9. That's about how many years you can expect the interest to require to double. Now, it's going to be a little bit less if you're compounding it a lot of times, like maybe even continuously. It'll take a little longer if you're not compounding it at all, but still, it's going to be around 9 years. So I figured, well, $10,000, you're doubling it, but then you're allowing it to grow half again as much, and I kind of did a geometric mean and got 11 years. But the bottom line is I knew that you'd have $8,000 after 9 years. And from that I just estimated based on long intuition, which you're not going to have that, but you can still use that rule of 72 to get a pretty good idea. And you could even construct a long-term graph of how your investment is going to grow.